So next problem says that a set A has n elements, and if a subset P of A is selected at random and after returning the elements of P, a set Q is formed, then the subset Q is now selected and we need to find the probability that the subsets P and Q are not having any common element. Now this is a very important problem, so listen carefully. We can have the set, or rather the subset P, to be an empty set, a set having one element, two element, three elements or n elements. So probability of selecting P if P is empty is nc naught upon 2 power n. This is because out of those n elements which are present in A, we are not selecting any element for the set P, hence it is nc naught upon 2 power n. This 2 power n is because it is nc naught upon nc naught plus nc1 plus nc2 up till ncn, because a set P can be formed in these number ways. We could have 0 elements in P, 1 element, 2 element or all the n elements of set A to form the set P. Hence the total number of ways of selecting P is nc naught plus nc1 up till ncn, and the favorable number of cases are nc naught because we have taken the set P to be empty. Similarly, if set P is having one element, then probability is nc1 upon 2 power n. And generalizing this, if the set P is having r elements, the probability is ncr upon 2 power n. Now we have got the probability of selecting a set P. Now we need to find the probability of selecting the subset Q in such a way that P and Q are not having any common element. So generalizing, for R terms, if P is having R, then Q will be having, then for Q there will be n minus R terms left out of the total n terms which were present in set A. So the probability of set Q to not have any common element with the set P is 2 power n minus R upon 2 power n. This is the general term for the probability of P and Q to not have a common term, that is the probability of selecting P, which was NCR upon 2 power n, into the probability of selecting Q, which is 2 power n minus R upon 2 power n. Now this R can vary from 0, 1, 2 up till n, because the set P can be either an empty set having no element, that is R is equal to 0. It can be a set having one element, two elements or all the n elements. So the required probability is the summation of this probability PR NCR upon 2 power n into 2 power n minus R upon 2 power n, R varying from 1 to, or rather 0 to n. So this becomes, since this is independent of R over which the summation is being done, so let us take this out common. This becomes 1 upon 4 power n into summation from R is equal to 0 to n NCR 2 power n minus R. We know that NCR x power n minus R is the general term for the expansion 1 plus x power n. So this is a general term for the expansion 1 plus 2 power n. So the entire summation becomes 1 plus 2 power n. So this is equal to 1 upon 4 power n into 1 plus 2 power n, which is 3 power n, and hence this comes out to be equal to 3 by 4 whole power n. Hence this problem, although appeared to be a bit tricky, the simpler part was first to form the subset P from all the elements of set A. This P can have either 0 elements, 1 element, 2 elements or up till n elements. So first of all, just form P, then try to form Q in such a way that P and Q cannot have any common elements. Then we multiply the probabilities of both the selecting of P and selecting of Q, taking R as a general term, and then doing the summation from R is equal to 0 till n, which is the maximum limit since n is the number of elements present in set A, and hence we have got the final answer as 3/4 whole power n.